SwiftUI gives us extraordinary control over the way our views are rendered. We can add things like real-time blurs, or adjust blend modes, or even control saturation of our images. Now, blend modes control the way one view is drawn over another. The default's called normal, and it means the pixels from one view are simply drawn over the pixels of the previous view. But there are many other options that control how colors and opacity are handled. As an example, we could draw an image inside a Z-stack, and then draw over it a red rectangle with a multiply blend mode. We'll say there's a Z-stack here with the image of Paul Hudson, because I just love seeing myself on screen, nice and big. Then we'll say there's a rectangle over that with a fill of .red, and as we're inside a Z-stack right now, it'll occupy the full screen. But if we said that red rectangle has a blend mode of multiply, look how it changes. You'll get sort of evil, demonic Paul Hudson. Now, this multiply blend mode has its name because it multiplies the pixels from the two views. All the pixels in Paul Hudson and all pixels from our red rectangle get multiplied together to produce a new color, and that's what you see. Now, the way colors work is very complex. Like dates, they are way more complex than you or I could possibly imagine. They're very, very hard indeed. But in simple terms, the pixels of my face, the pixels of the red, have RGBA color values, red, green, blue, alpha, or opacity. And they range between 0, none of that color, up to 1, all of that color, very roughly. Multiply multiplies those two things together. So it'll multiply a pixel from my face, it's red, with a pixel from the overlap thing, it's red, to produce a new final value, and it'll put it out. So if the source and destination, the previous and the overlapping views, have red values between 0 and 1, green between 0 and 1, blue between 0 and 1, and you multiply them together, the maximum value you'll get is 1 times 1. Full red here, full red here. And the minimum will be 0 times 0. No red here, or no green, or no blue, whatever happens to be, down the line. So we have maximum of 1 times 1 and 0 times 0, and this makes it really useful. In fact, applying a multiplier with a solid color like this one makes a really, really common effect, because blacks always stay black. Because black has a color value of 0. 0 red, 0 green, 0 blue. So no matter what you multiply that with, if it's 1, 0.5, whatever, anything multiplied by 0 is still 0. So blacks always stay nice and dark, like you can see down here. Super dark colors, whereas all brighter colors become various shades of the thing we're multiplying with. In fact, this multiply effect is so common, it actually exists as its own modifier in SwiftUI. We can say draw Paul Hudson with a color multiply effect of .red. Boom, the same result. Now, there are lots of other interesting blend modes to choose from, and it's worth really just spending some time experimenting to see how they work. Another popular one is called a screen effect. It's the opposite of multiply. It actually inverts your colors, then does a multiply, then reinverts and actually produces a lighter image rather than a darker image. As an example of this, we could render 3 circles inside a stack, overlapping, and then have a slider to control their size and their overlap. So we'll say there is an @state property, private var, amount is 0.0. That's our slider. Inside the body, we'll have a V stack. Inside there will be a Z stack. And in here, we'll draw our 3 circles. So we'll say there's a circle with fill of .red. A frame, how big our circle should be, will be width 200 times amount. So the circle gets smaller or bigger depending on how much we move our slider around. We'll add an offset so it moves to one side of the screen. I'll do -50x and y -80. And then a blend mode of screen. That's our first circle. If I press preview, you'll see a blank screen. You'll see anything here at this point, because amount is 0 by default, right? We'll then copy and paste that below twice. We'll say there's a red there, one below here red, and one below red like that. The second one's going to be green, and the frame width will be the same, but the offset will be to the right this time. So it's top left, top right, and so forth. Then the last one will be blue. And this will actually have no offset. So it will stay centered. So we have one in the center, one top right, and one top left in red, green, and blue. All attached to a mount, so they'll get smaller and bigger as we drag our slider around. Speaking of a slider, let's place that after our Z stack. I'll give this thing a frame with a width of 300, height of 300. And then below that will be our slider value $amount with a touch of padding on it. And then make it a bit clearer what's going on here. We're going to go ahead and add a modifier to our VStack here, which is frame max width infinity, max height infinity, infinity. One too many colons. And a background of black so it all stands out nicely, and then ignore safe area so it goes edge to edge. Okay, let's see how that looks. Our slider starts at 0, but as I drag it upwards, you'll see our circles start to appear like this. And then we get bigger and bigger and bigger. And when they overlap, like that. So they overlap in interesting ways, and they blend their colors together, get brighter and brighter and brighter, coming up to 0. So multiplying the inverse of these things ends up making brighter and brighter colors. We've got a screen effect on red, green, and blue now makes this white color. If you are extremely observant and have a good screen, like one of the fancy new MacBook Pros that were announced last month, or this month, soon, recently anyway, you might notice that the color in the center is not actually white. It might look white if you've got a less than Apple quality screen, but it's not. It's actually a very, very pale lilac color. And the reason for this is because when we say color red, color green, color blue, these aren't actually full colors. You aren't seeing pure red, pure green, pure blue here. You're seeing SwiftUI's adaptive colors. And these actually change the way they look based on the environment they're in, light mode and dark mode. And so you get an interesting shade of blue here that's not pure blue. It's slightly off blue rather than pure blue. If you want to see the effect fully how it should look with the pure red, green, blue, then don't use red, green, blue. You want to say exactly, I want the color of red 1, green 0, blue 0, and then down here would be the same thing, but red 0, green 1, blue 0, and then here would be red 0, green 0, blue 1. And now you have the pure versions of those colors. They're a bit garish, quite frankly. There you go. Super colors now. And now, right in the middle, you do get a full yellow and then full magenta. Cyan and fuchsia? Magenta? Turquoise? Cyan? Yellow? Anyway, you get the beautiful colors in the middle now. So we now have a lovely, lovely blending effect. And in fact, I have this tutorial in Hacking with Swift Plus. We make this plus a bunch of other things using the accelerometer. As you tilt your phone, it brings in different effects and blends and so forth. It's very, very nice. Separate. There are a host of other real-time effects we can apply, and we already saw blur back in Project 3. So let's look at just one more, which is saturation, which adjusts how much color is used inside a view. Give this the value of 0, which means no color, it's just pure grayscale, up to 1, the full sort of natural color. Now we could write some code to demonstrate both blur and saturation at the same time. If I undo, I'll press delete, it'd be easier. Let's go back to here. Okay, let's leave the slider in. Let's remove just the Z stack here. We'll say there's an image of me again, because obviously I love my face. Then resizable, then scale to fit. I'll give this thing a frame with width 200, height 200. A saturation bound to our amount. So I want to have 0 saturation by default. Then a blur where the radius is 1 minus amount times 20. Like that. So let's have a look, see how it's going to like that, if we're lucky. So there's me, nice and blurry. I can slide it upwards, and as I get higher and higher and higher, it will come in pin sharp and gain color as we go. So having the slider at 0 means image is maximum blur for us and color, sort of grayscale. As it goes to the right, it's going to gain more and more color and become sharp, all rendered at lightning fast speed.